Hello guys, welcome back to another video. Today we'll be talking about Gaussian elimination. In the last episode we saw how to look at linear systems from a different perspective, as a matrix times a vector that gives you another vector. So the matrix notation of linear systems. And today I want to talk about Gaussian elimination before getting into matrix multiplication, because we really need to understand what Gaussian elimination is if we want to understand the whole picture about linear algebra. So I think this is probably the most important topic for a beginner in linear algebra. So there are countless of videos on YouTube regarding Gaussian elimination, but I really wanted to try to explain it and give you an overview of what's going on, the big picture of linear algebra. So, what is Gaussian elimination? Put it simply, it's just a way to solve a linear system of equations. So, some equations, and we need to find several unknowns. Sometimes the unknowns might have just one value, for example, in this linear system. Sometimes some variables might depend on another variable, so there's an infinite amount of solutions, and sometimes there's even no solution. In this case, obviously, the solution is only one value of y and one value of x, and we'll see later on why. But how can we solve linear systems? There are countless of ways to do that. For example, we might just isolate two variables, for example, y. So we isolate y in the first equation, and we get y equals 2x minus 4. In the second equation, y equals to 2 minus 4x. I'm just rearranging the two equations, nothing crazy. And since y and y is equal, also this and number here and this number here are equal. So we can put them equal to each other. So 2x minus 4 equals to 2 minus 4x. 2 minus 4x. Now we can bring all the x's to one side and all the other numbers on the other side. So we get 4 plus 2x, that is 6x, equals to 4 plus 2, that is 6. So x equals 1. And we just found what x is equal to. Now, if we put x equals 1 in one of these two equations, we get that y equals 2 minus 2. Nothing crazy. But we just solved this system. We found x and y such that these two equations are both true. This means the left-hand side equals the right-hand side for both equations at the same time. And that's probably not new to you because it's something trivial. And also Gaussian elimination is trivial. I wanted to tell you, I wanted to prove to you that Gaussian elimination is trivial, is something easy. So what this method tell us to solve these equations? Well, we have two right-hand sides, two right-hand sides and two left-hand sides. What does this equal sign mean? It simply means that what is on the left on the equal sign equals what is on the right. They're basically the same number. This is what the equal sign stands for. So nothing crazy. So we know that we can add to an equation a number to both sides, and the equation doesn't change, but that number has to be equal. What I mean is that we can take the first equation, 2x minus y, and we can add any number a on both sides, and the equation remains unchanged. But now, this side equals to this side. They're two numbers, they're equal. So we can call these two numbers, but they're the same number, these two quantities that have the same number. So we get 2x minus y. Then we have this green number here, so plus y plus 4x equals to 4 plus the this number, that is 2. We can do that. We basically can add the same quantity to both sides of the equation. But now what is the cool part about Gaussian elimination? Is that we can simplify y because we have plus y minus y is simply 0, and we get an equation containing only x. And we also have to rewrite the second equation because then we need to find what y is equal to, as we did previously. So we can isolate x in the first equation, so nothing too crazy. We have 6x equals to 6, so x equals 1, and this is true because we found earlier that this is equal to 1, and we can turn to the second equation and find what y is equal to, and we get minus 2 if we bring 4x to the other side and make that substitution. So this is what Gaussian elimination tells us, and this is the first rule. We can add one equation to another, multiples of one equations to another, because the result doesn't change. But why multiples? Because in this way we just added the second equation, but we could have also added minus 2 times the second equation, plus 3 times the second equation. It doesn't really matter. The trick is that we need to add the multiple of the equation that leads to a cancellation of one of the two variables. For example, if the second equation contained a y and the second equation contained a 2y, and we wanted to, the first equation, sorry, contained a 2y, and we wanted to cancel out those y's, well, we could have multiplied the first equation by minus 2 times the second equation. So also the y term would become minus 2y, these cancel out, and we get only x to the first equation. So this is the trick behind Gaussian elimination. So we can add multiples. This also means subtracting if that multiple is a negative number, of one equation to another, and the linear system remain unchanged. Now, this is the first rule. The second rule is that we can just swipe two equations. This is not too crazy if it's seen from this perspective, because if we have this linear system here is basically the same. It's the same linear system. It doesn't matter what order the equations are written. It's just the same system of equations. I just swiped the first and the second equation, and as you can see, the linear system is the same. If you solve this system, you obviously get x equals 1 and y equals minus 2. Nothing crazy. Okay guys, so here are the three rules we found that are true for solving linear systems, and this is what Gaussian eliminations kind of relies on to solve linear systems. And let's see whether this is true for matrix notation. I should swipe these two because this way is better, because the x has to be aligned. So we have 2, 4 minus 1, 1. We saw it last time. We have the vector x and y, and this equals 2, 4, 2. This vector 4, 2. Now, if we swipe the rows and we compute the multiplication, let's see what happens. We have 4x plus y equals 2, and I should write it without abusing this notation. Well, plus y, and this equals 2, and on the other equation we have 2y minus y equals 4. As you can see, this is the second equation and this is the first equation, so it works, and also the other 3 works. But what I wanted to tell you in this video is that sometimes to carry all these steps we just take the column on the other side, and this matrix, we don't need x and y because we saw that it doesn't change, and we just create a new matrix, that contains the information of both matrices. We put this bar here, this vertical bar, and we put on the other side the other side of the equation, and we carry all the elimination steps on this matrix. For example, what we've done is just add the second row to the first one, so we're going to do that. We can write it in this way, on the top of the arrow, under the arrow, whatever you want to. The important thing is that someone understands what you're doing. So we just take row 1, and we add to row 1, row 2. So let's do it. We get 6, 0, 6, and here the second row stays the same. Now we can do even something else. We can just use our second rule and multiply the first row by 1/6. In this way, we can write it as 1/6 times R1. We get 1, 0, 1, 4, 1, 2, and here is basically the system almost solved. We can even reduce this even more, but it doesn't make sense for one of these simple systems, because now we can just rewrite our original system, that is now 1, 0, 4, 1, that multiplies x, y to give us the vector 1, 2. And if we solve this in the standard way, we get our usual result, x equals 1 and y equals -2. But now, how do we get from this matrix to this matrix here? This is what we're going to find in the next video, because we can find a matrix that, if multiplies both sides of the equation, also this vector here, gives us the new system. It's basically matrix multiplication, and also matrix vector multiplication helps us to keep track of all these steps we found with Gaussian elimination, and thanks to that we can find the inverse matrix and all of that stuff. So this is a topic for another time. This is just a basic review of what Gaussian elimination is. So for everyone who's interested in knowing details, this is not in row echelon form, because we still have this 4 here, and we should have rearranged the equation. But as you can see, for this simple system, it doesn't take a lot of time to just find what y is, since we now have a neat expression for x. It just tells us that x equals 1. So we're going to dive into more detail in the next video. This is just a basic preview, because I haven't been making videos for a while, so I want you to just slowly and go ahead on this series. So if you enjoyed this video, as always, subscribe to my channel, share it with your friends, leave a thumbs up, and also write down some comments. So as always, until next time, bye.